Hi everyone! So in this video we're going to be talking about different weather tools we use to measure different kinds of weather, and we're going to be talking about, well, what causes all of this weather and the earth cycles behind that, and also get into some of the tides and what causes tides. Also, this channel is part of a non-profit organization called One World, One Nation, where we try to provide children who might not have an access to educational resources and provide them with a platform in order to extend their learning for free. And so please subscribe to this channel to support this initiative. So let's get into it. So we all know what wind is, but how do we measure it? Do we scoop it up in a bucket? Well, not really. Measuring wind is not like measuring flour or cake or counting the number of inches of snow that fell on the ground. Instead, wind is measured by an anemometer, which measures the wind's speed. You might have seen the tools on top of a building, and it's basically based on how many times this anemometer will spin around in one whole revolution. And this way, the number of times it spins around tells us how windy it is outside. For instance, if it spins around a lot, that means there's a lot of wind pushing the anemometer to spin, and so there's a lot of wind speed, and that means it's pretty windy outside. Just like the opposite, if there's not a lot of wind, then that means the wind won't really be able to push this anemometer that fast in circles, so it shows that it's not really windy if this anemometer is not going around too many times. Just like it might be confusing to know that there's a way to measure wind, there's also a way to measure air. When I say measure air, I don't mean how much air is in the room, but I mean air pressure. For instance, imagine you are at a beach and in the ocean playing with your friends. If you were to put your head under the water, it might feel different than if you were to be walking around on land. But the water does not have too much pressure on your head when you're just playing around on the shore of the beach. Now imagine you were swimming to the bottom of the ocean with thousands of tons of water pounding on top of you. Well, that, first of all, is not a good idea, and also you would probably be crushed because there is lots and lots of pressure of the water on top of you, because water does have weight, and all of that weight is put on top of you. So there is a lot of water pressure. So you can see how the difference between the two depths of water and the different pressures they have. Well, the same is true for air. On ground, it doesn't seem like it, but there is a lot of air pressure on you on the ground than there would be if you were to go up onto a mountain, because there's just not that much air on top of you, so there's a lower air pressure. So the higher you go, the less air pressure there is. So there's actually, again, a lot of air weighing down upon you, because just like water, air also has weight. So it changes the pressure with the change in height, or how high you are above the ground. So when we measure the different air pressures at different altitudes or heights, we can use a barometer to do this, and it basically looks like a scale where you just hold it and it will move its arrow to tell you what the air pressure is. This tool can be used in helping us predict if there's going to be bad weather, because air pressure will change according to the weather. Okay, so the last tool we're going to be talking about is a tool that measures rain. So the tool that we use to measure rain basically collects the rain, and it is called a rain gauge, and we can see how much it rained in a certain period of time. It is important to know how much it rained, especially when it rained a lot, because it can show you if a flood is about to happen, such as if there's a lot of rain in a short amount of time, and if this is going to cause damage to buildings if it's that severe. Also, rain is very important for jobs in agriculture, like growing crops, and it is important for farmers to record how much rain there has been in a season so that they can understand how many crops are growing and if they need to add more water to their crops through irrigation, or if there was enough rain for their crops. And this saves them water bills and prevents them from having to water their crops when it's going to rain later that day. We have talked about many different We have talked about many different kinds of tools we use to measure different weather we may encounter in our environments, but what causes all the different environments and conditions of weather on Earth? Well, the major cause of weather, or the seasons, is the tilt of the Earth, of the axis of the Earth, which causes the uneven heating of the Earth's surface. So when we think of the Earth, we think of a North Pole and a South Pole on two halves of the Earth. Well, this Earth is actually tilted on a 23.5 degree tilt, which means that some of the Earth is closer to the Sun and is getting more direct radiation from the Sun than the other half of the Earth. So we see that some of the Earth is closer to the Sun and thus warmer as compared to the other half, but what does the tilt do? So basically, during one part of the year, the northern hemisphere, or the top part of the Earth, is tilted towards the Sun. As it revolves around the Sun, and since it's tilted toward the Sun, it is getting warmer for this part of the year, for this part of the Earth, during this part of the year, and this creates the seasons of summer and spring in the northern hemisphere, as again, it's tilted toward the Sun, and it's getting direct radiation and is warmer. But then, sometimes the northern hemisphere is tilting away from the Earth, and the southern hemisphere is tilting to the Sun. And this is just caused by when the Earth revolves around the Sun, the tilt always stays the same at a 23.5 degree angle, but when the Earth is actually revolving around the Sun, when it gets to the other side of the Sun, the southern hemisphere will tilt towards the towards the Sun, and the northern hemisphere will tilt away from the Sun, and this actually causes the northern hemisphere to experience winter, since it's tilted away from the Sun, and the southern hemisphere to experience summer or spring because it's tilted towards the Sun and is getting direct radiation from the Sun. So again, the major cause of the bigger weather, like the seasons, is the tilt of the Earth on its axis. So like we talked about how the Earth is tilted on its axis, and the revolution of the Earth around the Sun causes the seasons to change in the two hemispheres. There is another Earth cycle that causes tides to occur. This cycle involves not only the Sun and Earth, but also the Moon. Each of these bodies in space has a connection and gravitational pull on each other that allows them to stay in orbit. And this very gravitational pull that we see between the Moon, the Earth, and the Sun is also what causes the tides. For instance, when the Moon is circling the Earth, wherever it is, the Moon is slightly tugging or pulling on the Earth. This pull does not cause the Earth to move closer to the Moon, or the Moon to move closer to the Earth, but it is what causes the tides to get pulled in the Moon's directions, or the ocean or water on the Earth's surface to get pulled in the Moon's direction. This lifting of the water causes tides, and it actually causes really large tides called high tides at the beach or in the ocean, because it's essentially the gravitational pull that causes the tides to be lifted closer to the Moon, and that means that there's going to be a higher tide or a higher wave on the ocean. Just like the Moon has a gravitational pull on the Earth, so does the Sun, and the effects are essentially the same. The Sun pulling on the Earth does not move the Earth closer to the Sun or the Sun closer to the Earth, but it causes the water to be brought up and rise, forming the high tides. Now there are two kinds of tides, spring tides and neap tides. Spring tides occur when the Sun and the Moon and the Earth are in a straight line, in any order, and this causes the tides on either side of the Earth to be pulled and have high tides, or really big tides, while the other sides of the Earth do not have high tides and have low tides because nothing is pulling them. The other kind of tide is the neap tide. This is when the Moon, Earth, and Sun form a kind of corner in space, or a right angle, when the Moon is at first quarter or third quarter in its moon phases. This basically causes the tides on the face the Moon to bulge outwards and have high tides, while the rest have moderately low tides. So that was it for this video. I hope you learned a lot about different weather tools and different Earth cycles that cause weather and even tides. Here are a couple of citations I used for the pictures for this video. Here are a couple more citations I used for the pictures for this video. Again, I hope you enjoyed, and please subscribe to this channel, and thanks for watching.